Hello everyone, this is Dr. Mainak Saha, Assistant Professor in the Department of Electronics and Communication Engineering of Ramakrishna Mahadev Government Engineering College, Purulia. Today we will have our discussion on solar cell fundamentals. This is the outline of today's discussion. Let us start with what basically a solar cell is. Solar cell is a device that converts the photonic energy into electrical energy through photovoltaic effect. As sunlight is abundant and a free source of photon, these devices are mainly aimed at working with the solar energy. That's why the name solar has been given. Sometimes the term solar cell is reserved for devices intended specifically to capture energy from sunlight, such as solar panels and solar cells, while the term photovoltaic cell is used when the light source is unspecified. Now let us have a look at the history of evolution of solar cell. Solar cell has gone through several stages before it has reached the modern form. The development of the solar cell starts from the work of French physicist Alexandre Edmond Becquerel. Becquerel discovered the photovoltaic effect while experimenting with a solid electrode in an electrolyte solution. He observed that voltage developed when light fell upon the electrode. In 1883, that is about 50 years later, Charles Fritz constructed the first true solar cell using junctions formed by coating the semiconductor selenium with an ultra-thin, nearly transparent layer of gold. Fritz's devices were very inefficient, transforming less than 1% of the absorbed light into electrical energy. In 1927, metal semiconductor junctions were formed. In this case, they were made of copper and the semiconductor copper oxide. They were used to make the solar cells. By 1930s, both the selenium cell and the copper oxide cell were being employed in light-sensitive devices, such as photometers for use in photography. These early solar cells, however, still had energy conversion efficiencies of less than 1%. Russell Ohl in 1941 developed the silicon solar cell, and it showed better efficiency than the earlier made selenium cell and the copper oxide cell. Three other American researchers, G.L. Pearson, Darrell Chapin, and Kelvin Fuller, in 1954 demonstrated a silicon solar cell capable of a 6% energy conversion efficiency when used in direct sunlight. By the late 1980s, silicon cells, as well as those made of gallium arsenide with efficiencies of more than 20%, had been fabricated. In 1989, concentrated solar cell, a type of device in which sunlight is concentrated onto the cell surface by means of lenses, achieved an efficiency of 37% due to the increased intensity of the collected energy. In general, solar cells of widely varying efficiencies and cost are now available. Now let us have a look at the working principle of solar cell. So here in the left side of our slide, we are having the diagram of a p-n junction diode under equilibrium. A solar cell is basically a normal p-n junction diode. So in this structure, we can find out that there are lot of immobile negative charges on the p side at the junction, and similarly there are a lot of immobile positive charges near the junction in the n side. So they form an electric field which is directed from the n side to the p side. In the right hand side, we have shown the energy band diagram of this p-n junction diode. It shows that the electrons in the n side are at a lower energy level than the electrons at the p side. Now this electric field is there in the p-n junction diode under equilibrium. Now when light falls in this solar cell, then the photons are injected, or photons are having a chance to interact with the electrons that are lying in the valence band of the structure. So what happens there? Let us have a look at that. So when the photon interacts with the electron in the valence band, it transfers its energy to the electron, and as a result, the electron moves from the valence band to the conduction band. In this process, it leaves behind a hole in the valence band. Now these electron and holes that are created by the interaction of the photon, they are present under the electric field. So what happens? The electric field separates the electron and hole and transfers them to the external circuit. As a result, we can have a current flowing through the external circuit. Now this is an exaggerated picture where it has been shown that the current is directly driving a load, which is not the case, not the practical case for a solar cell device. This current is used to charge a battery, and in turn the battery is used to drive a load. Let us move to the summary of our discussion. So in summary, we can say that solar cells are devices that can convert optical energy into electrical energy. The gradual improvement in this field has made it a reliable source of electrical energy. And most importantly, it provides a great option for green energy production and storage. For further discussion, you can have a look at these books. Thank you.